Hello guys, I hope you are all doing well. In this video we'll be solving the problem LeetCode partition labels. Before we get started, make sure you subscribe and like the video. Without further ado, let's get started. So the problem is that they give you a string and they ask you to partition it into as many parts as possible so that each letter appears in at most one part. And they return a list of integers that represent the size of these parts. And note that all the partition is done that after concatenating all the parts in order so that the result string should be the same as the input string. So to solve this problem, we're going to use the sliding window technique, and the window going to have a start and end pointers. Then we're going to iterate throughout the string, and that each time we check if the character is already in the window or not. So let's say we have this input string. The first thing we're going to do is to create a hash table or hash map to keep track of the last appearance of each letter in the input string. Then we will set two pointers, start and end, that will represent the size of the window. And we will initialize an output array to store the size of each partition. So after iterating throughout the input string, we will have the hash map with the keys as the letters, and their values are the index of the last time we've seen the letter in the input string. For example, the letter A. The last time it will appear inside the input string is at index 8. And we do the same thing for all the other letters. Then we're gonna use the hash table in the for loop to check if the current character is already in the window or not. Let's start at the first letter, which is A. So we'll look up inside the hash table for the letter A. So the last appearance of the letter A will be at index 8. So what we need to do here is to expand the window by moving the end of the window to be at index 8. And we move to the next letter B. So we use the hash table to see the index of the last time it's appeared inside the input string. So here the value is 5, means the letter is inside the previous window. Means the letter is inside the previous window. So we don't need to update the end of the window because the previous window it's already larger than that. And we move to the next letter C. The same thing gonna happen because the index of the value of the letter C is inside the window. So once the index of the for loop or once the iteration reach the end of the window, we're gonna return the length of the first partition. In this example, it will be 9, and we push it inside the array result. And we start another window. The start and the end gonna be at the next letter after the first window, and we're gonna repeat the same process until the loop reach the end of the input string. Means the right pointer gonna be updated to be the maximum of its current value or the index of the letter in the dictionary. And once the current index of the for loop is equal to the end of the window, we append the length or we add the length of the current window to the array result, and we move the start to be the end plus 1. Finally, we return the result array that contains the length of all the partition we made. That's it guys, so let's jump at coding the solution. First, we initialize an empty array that's gonna be the output. Next, we create a hash table and we set the key to be the letter and the value to be the index of the last time the letter appear and the input string, and we're gonna do that by looping over the input string. Then we initialize two pointers, start and end, that represent the window. Then we're gonna iterate throughout the input string and each time update the end of the window to be the max between the current end of the window and the value of the current letter inside the hash table. In simpler terms, we're gonna check if the current character is already in the window or not. Once the current index of the for loop is equal to the end of the window, we push the length of the window of the current window to the result array, and we update the start to be pointing to the letter after the end of the window. Finally, we return the result array. So the time complexity for this solution is often where n is the length of the input string, and it's because we are iterating throughout the input string. And for the space complexity is also often because we are using a hash table to store the last appearance of each letter in the input string, and also because the size of the hash table is proportional to the size of the input string. Thanks for watching, see you in the next video.